We're tackling the problem integer break, which we want to try and solve with minimum complexities of on squared time and on space. We're given an integer n and need to break it into the sum of k positive integers, where k is greater than or equal to 2, in such a way that the product of those integers is maximized. Our goal is to determine the maximum product we can obtain. In the examples we're given, starting with n equals 2, the maximum of that is 1. As you can see, we're breaking it into two integers, 1 plus 1, and the product of those is 1. In the second example, we have n equals 10, and in this case, our maximum is 36. We can break it into 3 plus 3 plus 4, and then the product of that sum would be 36, as you can see there. So, quite a complex problem. Let's take a look at the four possible methods we can use to solve this. You have a choice between A, DP with memoization, B, simple recursion, C, backtracking, or D, greedy. I'm going to pause for a couple of seconds while you make your choice. So, for those of you who are able to get this, congratulations. And for those of you who just want to see the code, the answer here is A, DP with memoization. We're going to forego the brute force approach and simply take a look at the optimized solution. I hope that that's come up now. Okay, so in our optimized solution, we're using dynamic programming with memoization. The int break function is being used to calculate the maximum product of breaking an integer n into all these positive integers. It uses memoization to store previously calculated results and recursion to compute the maximum product based on different breakpoints. It iterates through all these possible breaks and recursively calculates the maximum product for each, storing the maximum product found in the ret variable, which we'll go into in our line by line. Eventually that's what we're going to be returning. The integer break is the function we were given by LeetCode. It's the entry point to our solution. We use it to initialize our memoization array and then call the int break function with the input integer n and return whatever the maximum product found is. So let's look at this line by line, and we'll start with this constant up here. This is the maximum as defined by LeetCode, and we use that to to initialize our memory array. Let's go to the entry point now, the integer break function. So all we're doing here is we're mainly using it to initialize our memory array with -1. That's done to indicate that no results have been calculated yet for that position in the array. However, you'll note that we also use a check here, checking if n is equal to 2 or 3, in which case we're returning n minus 1. They're guaranteed to be the answer. When n equals 2, as you've seen in example 1, the answer is going to be 1, and when n equals 3, the answer's guaranteed to be 2. For those of you with maths problems, 1 times 2 is 2. Now, let's take a look at int break, which is called with our input integer n. This will be returning our maximum product for a given integer. The first thing that the function checks is whether n is equal to 1. If n equals 1, it means we've reached our smallest breakable unit. So we return 1 as the maximum product in this case. We then check if the result for n has already been calculated and stored within our memory array. If so, we return that pre-calculated result rather than recomputing it. If you're having trouble understanding this, the ret variable is simply this memory x, which is a reference variable. And if ret does not equal -1, it means that we've already calculated a result. As you'll remember, we initialized our array using the memset function, making all of the entries -1. If it's not -1, it means we've calculated the result already. This helps us save a lot of time and increases the performance of our algorithm. In any case, after that, and assuming we haven't already returned that result, and ret is -1, we then set ret to n here, which is a default value. We iterate for all the possible breakpoints going from 1 all the way up to n-1. For each of these breakpoints, for each breakpoint I, let's say, we recursively calculate the maximum product for the two parts, I and n minus I. We multiply I with the maximum product of n minus I, updating ret if a larger product is found. As you can see, we're using the maximum among them. And that's pretty much it. We are finally going to be storing the calculated result in the memory array for future reference, returning ret, which is, as you should remember, memory n. Returning ret, which is our maximum product here. Okay, so the integer break function simply initializes our memory array and then makes the call to the int break function, which will give us our result. That result being the maximum product we can obtain from an integer n. I think that my solution doesn't do this course justice. I'm going to point you in the direction of it. Dr. Ibrahim does a much better job of breaking down the integer break problem and offers a clearer and coherent version of the dynamic programming solution for it. In any case, our application's more focused on getting you to understand and recognize the best method to use for specific problems, and dynamic programming with memoization will help with the integer break problem. You can check out the code in C++, Python, or Java, and I definitely recommend writing out the solution as you do it, and make use of the debug function to fully understand what's going on here. That's it for the integer break problem. The next problem we're doing in this playlist is the min cost climbing stairs. Thank you very much for watching.